I'll make a small presentation about what we're doing here, and let everybody else to join. So hi everyone, welcome. And so that's our 7th FHIR meetup. So I want to share first of all a few links. So first link is we have a community to discuss the meetup, propose speakers, and propose topics for the next meetups in Telegram. The link is FHIR_meetups. And all these meetups are recorded. So there were already 6 online, and there were some offline meetups in the past. And you can go to YouTube and watch. There were some interesting topics already, like about SDC, about profiling. I mean, there are quite a lot of topics. Access control we discussed was very hot meetup with a lot of good speakers. Yeah, and it's totally community driven. So if anybody wants to speak at one of the meetup, we will totally welcome you, and just reach out to us. So one thing we always try to do at the meetups, we discuss what were the news, mostly asking speakers what happened over the last couple of months in the FHIR world, and what's coming around FHIR. So one thing was a pretty big rule published by ONC, which perhaps will affect interoperability in the United States significantly. And one big FHIR event is coming in May, but I think it's already a good time to start preparing. It's a FHIR Connectathon. I think it's the last virtual event. It's cheaper than going to real events. And if anybody never been to the FHIR Connectathons, it's a good opportunity to try from the convenience of your own home. Any other news? We have Grahame with us. What are the FHIR news? Can you still hear me?
Yeah, hi. Sorry.
Just asking if you can share any news, like we're discussing any interesting news.
Well, yeah. I hope that everybody here saw our solicitation for feedback about R5 that I published a few days ago. Give us your opinion on where we should go with R5. It's getting harder to do, the base FHIR stuff. So let us know what you think. That's probably the biggest news. In other news, well, I would love to see everyone in person, but we're still virtual in May. I can't think of off the top of my head of other news. Yeah.
Oh, thank you, Grahame. Michael, any news from CSIRO, Ontoserver?
Yes, I guess, well, most of the Ontoserver news I'll talk about later. Otherwise, I guess the thing to keep an eye out for is our FHIR native analytics platform called Pathlink, which I'll have a link for later as well. But that's an open source project that a number of people could be quite interested in.
Thank you. Nikolai?
Yeah, hi, everybody. Nice to meet you. So from our side, I know we're as usually kind of working on superset of structure definition on the model, on the brand new modeling language. And what we're trying to achieve is kind of build a Lego for health IT, so the model-driven system where you can configure every aspect of your server. So that's, I think, the important news from us. So we almost finished API constructor, so the users can configure what specific operation, what specific resource they want to see. And it as well has very nice features about the security. So you may describe some different type of middleware and create kind of safe operations, which you don't have to cover with a lot of access policies, so they're safe. So I think this is major news from our side.
Thank you, Nikolai. All right, so today's FHIR meetup, approximately 2 hours, 30 minutes, 3 presentations followed by discussions. We really want to make it very interactive. So I asked all the speakers to, ask questions to other speakers. I want to ask the audience to, join, actively discuss the topic. We have already 82 participants online in the Zoom. So hopefully we'll have a great conversation. So please have your questions ready. And the first speaker, I think, doesn't need to be really advertised on or anything, but I want to welcome Grahame Grieve, and thanks again, Grahame, for joining the meetup. Grahame was founder of FHIR Standard and leading FHIR Standard development with HL7. His company name is Health Intersections, and I like the name of the topic, part of the terms. So welcome, Grahame, please.
Thanks, Pavel. Hey, so people should ask questions in a Zoom chat, yeah?
I think Zoom chat is great, yes, but also if you finish the topic, we can just talk, right?
Yeah. Okay, all right. So that's where you can do what I'm speaking. Hey, everybody, welcome. Nice to be here with you. Thanks for joining. I'm kind of hoping, that someone else will speak next time, and so I can just watch. But let's get my presentation going. Okay. Yes. Okay. Here we go. Okay, so I'm talking about terminology, and just for fun, I called my talk "Lord of the Terms," but actually, yeah, there's a bit of a reason. So I've only got half an hour. I'm just going to give you a kind of a broad perspective of where I think we're going with terminology, and trying to give you a sense of perspective. We won't have that many details, but are you a lord of the terms? And so your challenge is that everybody uses terminology. I don't know anybody who doesn't. People often don't think that they're using terminology, but if you're using enumerations in your code, or you've ever made a list of words, no, you're using terminology. And the entry level cost is pretty much zero to start using a terminology, and you don't have any choice. And so everybody does. It's just, that's how it works, right? But what you find is the complexity of what you're doing grows and grows, and all the way up to super complicated things like ontologies, and maybe I think of the worst case of all is snowman CT. And the cost of doing that eventually becomes infinite. And of course, no one can pay that cost. So, but you all have to deal with this. You have to deal with it well too. You have to manage your terminologies well. And so the question that everybody who's doing anything in healthcare should be asking is, am I a lord of the terms, or the terminology is going to master me or master you? So that's kind of the frame I wanted to look at it through. And I've worked with quite a number of dev teams, whether they're developing national programs or products or within an institution. And the terminology part of the problem remains an ongoing challenge for them. So the first thing is about building your terminologies. You need to forge your terminology that lasts. And the thing is, it's really easy to dive in and make a list of codes. And without really thinking about what you're doing, and it's going to hurt you. It's going to, over time, because a lot of the price is downstream. And if you invest and know what you're doing and do it well, then your terminology will last and serve you through the ages. And so invest in your treasure and put your power in there. Now, a good place to start, and how do you do that? What are you supposed to do is Jim Smirnov's Desiderata. Now, I haven't met Jim for a few years, but he published this Desiderata for how to make a good terminology. And some of it's really obvious, but the further you get into this, the harder it gets to do it really well. But this is what you should consider around defining a domain that you're trying to make a terminology for, and really thinking about what are we actually doing, and then covering the scope in terms of both depth and breadth. And as soon as it gets more complicated, and I think about this, it's about like 10 terms. By the time we get to 10 terms, it's probably more complicated than a simple single list. You're going to have different axes of thoughts in your list. And you can start thinking about how do they interplay with each other. And it's not unusual to see, even we've got code systems in FHIR with 4 terms in them, of which the 4th term is a intersection of 2 of the other 4 terms. And so you think really carefully about how it plays out, and it's probably useful if you get over 20 or 30 terms to start thinking about, should I use a grammar? Painful but necessary. And then the next one's pretty obvious. You should define your terms with a clear concept, a clear description of the concept, and you should close the definition. And that's what people often don't think about, that is you define what you want to say, but then you go back and say, but what do I need to say that this thing is not? How do I need to close the boundaries so people are sure what I didn't mean? You shouldn't have more than one way to describe a thing. People should look at the list of terms and go, I know which term I need. That's actually turns out to be really, really hard in practice. You're allowed to do synonymy, and it can be useful to document terms that have the same meaning, which is not quite the same as the previous one, right? If you document that these things do mean the same thing, then you only got one way to describe the concept. You probably need, as I said, if you've got multiple axes, different ideas in your hierarchy, probably need different multiple classifications and hierarchies. And the adjunct idea of that is things move around your hierarchy a lot as you realize how you want to change the way you express your relationship. And then you should try and use the common approach to defining your terminology as ruthlessly as you can. This stuff is really hard. And I know when I first started, I was looking at this list going, really? You don't need to do any of that. It's much simpler than that, but it's not. It's about investing in the future. And finally, make sure you're explicit about how your concepts relate to each other. That was a really quick explanation of a huge subject, and there's a reference there, and Pavel will send your slides out, or someone, Nikolai maybe. And so worth understanding that really well. So forge your terminology. A well-made terminology lasts, and Smirnov's Desiderata is a good guidance. But as well as that, Jim Smirnov's Desiderata is all about how you author the terminology. And it matters, but it's not all that matters, because also you need to have a really clear idea of how you'll manage it, how you'll version it, how you'll distribute it, how people will work with it. And it's just as important to work through those things. Now, sometimes you already have a framework for managing and distributing, but other times it's a whole separate question. How do you do versioning? And the question is, will your terminology, the terminology becomes an agent for you? Will you be, what kind of agent will it be? One that reflects well on you, or one that possibly doesn't reflect so well on you? And I've always thought that you can tell a lot about an organization by looking at its terminology. and how it's thought through its terminologies. So I recommend to all of you to put, real work into forging your terminology well. Now, the first thing I want to tell you about is CTS2. So this predates FHIR. It was, you might call it the original terminology service. The focus of CTS2, because I worked with the development team that developed it, was managing and creating terminologies. And as such, the CTS2 model, which is, it was a pretty heavyweight service, but it was fully engaged with the complexity of terminologies and really grappled with them, with that deeply. And the terminologists who defined CTS2 were very focused on what do you need to do to get terminology management correct. If you go back and look at my ballot comments, I said, this is not the service we need. And so the FHIR service doesn't do that. FHIR service, the whole approach to terminologies is around publishing and using terminologies. That was our focus. How are you going to, but actually that raises a question. For those of you on this call who work within HL7, that raises a question, which is how is HL7 going to actually manage terminologies? We chose not to. I'll come back to that. And now we're actually managing terminologies even after we chose not to make that explicit in FHIR. It raises a question for how we're going to do it, and also raises a question for how everybody else is going to do it. We'll come back to that. All right. Now, when it comes to how I thought about terminology in FHIR, and very much the way FHIR terminology works comes from a discussion that I had with one of the co-chairs of the vocabulary committee 10 years ago, last month. What would we try to achieve? And I guess I would summarize it up as, when it comes to terminology, the whole process matters. You've got to define them well, you've got to distribute them well, you've got to implement them well, you've got to bind them into what you're doing really well. And all of the parts should be in harmony with each other. It's been a huge transformation for HL7 as we've driven that into the FHIR specification and the standards community. And it's also been a huge transformation for the implementer community. Yeah, back when we started this, if you look back at version 2 basically said, hey, there's a place where you put codes. We don't say anything more about that. And over time, that became more and more challenging for us to express how things work, because so much of the meaning goes in the codes. And the other part of our approach is that, done well, terminology can save your empire. So it's your fellowship of the ring, as it were. So let's dive into FHIR and see how that works. First of all, there's a real challenge around terminology, and it's really well shown in the observation resource. So observation has 5 codable things that play off against each other. It's got a category for the general kind of observation thing this is. It's got a code that specifically identifies the observation. It's got a code, a true optional body site, an optional method, an optional specimen. But if you've used, and the specimen's a reference to another resource, which is basically, for this purposes of this conversation, another codable concept that describes a specimen. Now, the thing is, some ways of coding resources, particularly LOINC, the body site and the method and the specimen are part of the LOINC code. And the category is implied by the LOINC code, at least some of the categories, possible categories. So you can have one code and you say, well, I don't need a body site or a method or a specimen or a category, I'll get rid of them. But then you get other kind of observations where you use limit codes or local codes or machine codes from IEEE. And they won't tell you what the body site and the method is. You actually have to look, or maybe you're doing a radiology measurement, imaging measurement, and using a DICOM code. And it's actually pretty common. I used to do radiology system, about half our customers had pre-coordinated codes for modality and body site, and the other half used a short list of modality codes in the code and a long list of body sites. And so you can trade between these. Which is there a right way? Well, maybe in theory, but in practice, everyone's all over the place. So the first big part of the challenge is your terminology and your content model, information model, they're not independent of each other, and how they relate matters. So let's talk about the FHIR terminology subsystem. First of all, we have a code system, and it defines a set of concepts with a coherent meaning. In principle, a code, a display, a definition, it's maybe some properties. And there's lots of examples. So with the big high-profile examples, SNOMED CT, LINK, RX norm, HGVS is the genetic coding system, ICPC and its variants, MIMS is an Australian one, ICD-X and all the variants there, there's lots of them. You see this, I used this slide in Australia, a couple more Australian coding systems. A local hospital drug formulary is a terminology. Application has a configuration table or a list of enumerations in a Java class. All these things are all terminologies, they're all code systems. So then in the FHIR world, you take a code system. No, hang on. So code system resource allows you to define the code system itself, its metadata, and then the concepts in it. Codes display as properties. And those are the fundamental language you use to define a code system. Now, code systems can be pretty small, and the smallest we've got in FHIR, I think, is 2 codes. Or they can be really large, up over 500,000 codes, which SNOMED CT distributed definition framework is over 500 now. And some of them, SNOMED CT, for instance, we don't actually bother producing a code system resource for them. We just assume that you'll have a system that knows how to pretend that it has a code system resource as implied by the RF2 distribution of the SNOMED, distribution that you're using. So you don't actually need to have a code system resource per se, but we know what it would look like if we actually had one. I know Michael's played around with them, but they just get unmanageably large because it's a general purpose format, and the SNOMED RF2 format or the LINK CSV tables or the RX norm RRF tables or so forth, they're all very optimized for the distribution of their particular way of thinking about the terminology they're doing. And we never set out to solve that problem. We wanted to solve the general case, lots of small code system problems. So code system resource often doesn't actually exist for some code systems, but you can behave as if it exists. Then, having a code system, you take a value set. And a value set is a selection of a set of codes for use in a particular context. Now, I'm going to be honest with you. The term value set is like the worst possible term you could possibly come up with for this thing. And I tried to get them to use a different name for this idea in FHIR. I mean, what's a value set? Who knows? But it should be like code system selection list or something like that. But no, we're going to keep using value set because that's the words we were using, which really underscores that this is the blind leading the blind here. Totally. I mean, that's the way the world works in this space, The only thing you could hope for is maybe not a blind person, but a wizard, and the wizard will say to you, I have no memory of this place. So, we just have to accept that things are not perfect in this space. And we keep using the words value set, but it's a selection of a set of codes for use in a particular context. So a set of codes, you can include codes from code systems, more than one code system. You can do that by listing the codes individually. Bang, 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 bang. These are the codes. And that's the nice, simple case that we all love. And it's not the real world case that we all deal with, because very often you choose a set of codes by the rules. For instance, all SNOMED codes in a particular hierarchy, or all LINK codes with a particular matrix, for instance. And we use value set resources to define conformance rules, which is how you see them in profiles when we publish FHIR implementation guides. But you can also use them to define user interface functionality, to define system capabilities, to code up clinical decision support rules. If this content is in this value set, then this rule applies. And of course, we have a functional service built around this, which I'll talk about, which is the terminology service. Okay, so that's the value set resource. Now, when HL7 insiders are well used to this separation between a code system and a value set. But when you actually go out into practice in vendors, in providers, with normal developers who haven't been through the training HL7 likes people to have, you'll find that, you know, code systems value sets are very mixed up, and it takes people a real thinking process to get your head around why are they so different and why do you separate them. So it's not unusual for me to see an application table or an Excel spreadsheet or an Access database or something that has a list of codes, and you mix LOINC codes and custom codes because you didn't know what the LOINC code was, or there isn't one. Then the only way you could know that it's a LOINC code is it's got the distinctive LOINC format. And no, we've said keep your definitions clean and separate out the definition and the use of a concept. And it's certainly an education process probably many of us have been through to have that discipline. And in the context of FHIR, we've basically said you've got no choice. You've got to have that discipline, and you've got to retrofit that discipline into your existing content if, you know, you have existing content. Then, have you got a code system and a value set, then you bind an element definition to the type and the value set reference, a type of binding and the value set reference. So you look at an element and say, in the definition of this element, we're going to tell you what value set it's bound to, and then that will tell you what codes can go in it. So here's a set of examples from US core. A US condition has these 4 codable elements, all with bindings to particular US, I believe there's a US one, so these certainly are. These are the codes that we use in USA for these elements. And so a valid category will conform to this binding. I'll come back to this little part later. And in the element definition itself is a binding that has a strength, which is the bit I'll come back to, a description about how you would use the binding and a reference to a value set. So this element must conform to this value set. And finally, you have actual elements, content and actual resources, and the element conforms to an element definition, and it does that because of the context it's in. Either the resource declares a profile directly and says, hey, I conform to this profile, or it's assigned a profile that it must conform to in its context of use, or at minimum, it always must conform to the element definition in the base specification, base FHIR specification. So an element always conforms to at least one element definition, and it may need to conform to a bunch of others. And then the element refers directly to code systems. So that's the layout. And so what an element looks like fundamentally is a coding data type. These 4 properties, system version, code, display, are the things that we repeat everywhere. Sometimes they're defined and not exchanged. Other times they're exchanged. Sometimes they're spread into other types like quantity. But fundamentally, those 4. The system is a URL reference to the code system, and it's key. Then there's a version, which is the stated version of the code system. Now, sometimes you need that. Sometimes you shouldn't have that. I don't have time to dive into that. Code, which is a symbol of a set of characters defined for the concept in the code system. And then a display. And the display is optional. I mean, they're all optional, but if you want to have meaning, you've got to have at least a system and a code. And the display is optional, and it's for human representation, but But given that you can look up the code system and get the display is not, that important. You can just drop it off. But it doesn't make fun for developers reading the resource, trying to understand it, and they've got to go and look up at a different table. So it's kind of like a denormalization for human convenience. But maybe you'll send the content to a patient device like an iPhone. It doesn't have a local terminology service. It doesn't have a local copy of Snowman CT loaded. Well, maybe it does, but you can't expect it to. And so if you put the display in, everybody can get it. So that's kind of the context for where you would use display. Some examples in that sometimes in FHIR we use a code, just a plain code, and the status of confirmed. And in that case, the code system and the version are fixed in the definition of the element, and it's known. And so you can look up the definition, and we expect everybody to look up the definition because they're everywhere and ubiquitous. Whereas other things, in RX norm code, for instance, you provide a reference to RX norm, the code, and that's the display in RX norm for the code C3214954. Or sometimes a codable concept with a set of codings, but always comes back to those same 4 properties and some text, which is what the user really meant when they used the code, which is the nearest code they could find. So that's the actual element reference to a terminology. The binding strength, unfortunately, in a nice simple world, we just say, here's a set of codes, you've got to use one of these codes, that's the end of the story. But of course, we don't live in that world. We live in a world of complicated complexity, and it's constantly changing and moving around us. And so we have extensible bindings. We say, well, we've got these codes, but maybe you run into a concept that we don't know about, but you're going to need to use. So if it's not one of these codes, you can use some other code. And that's extensible, and it's slippery and horrible, and we all don't like it, and it's the real world that we live in. And sometimes in FHIR, we just say, hey, here's a set of codes we encourage you to use or to think about, because we can't get agreement about what codes everybody should use. So you'll need an implementation guide or a profile or something to actually move up this table towards required, which is where you really want to be when it comes to implementation. It's just really hard to get there. So value sets are kind of challenging because there's lots of complexity and power in a value set. You have late binding of versions. Sorry. And I've got to look at all the chat. So I haven't seen any quick questions I should answer in the chat. I'll keep an eye on it now. There's lots of complexity, late binding of versions and hard to compute expressions like ECL and Snowman CT value sets, modular code systems, human language variability. Think about terminologies that really astounded me when I first got involved with them is you can just dive in and spend your whole life in it. And you really need specialists to do it. And vendors just can't afford to have such specialists around. It's just can't do it. And most software, you just give me a list of codes, man. I can't deal with all this complexity. And so, back here. And so we defined a terminology subsystem with a service. So I've talked about the value set and the concept map, the framework, and we defined a bunch of functions, which are the functions you need to use as a consumer of terminologies. I'm just going to quickly run through those. Time flying away from me. So you can expand a value set, say what codes are in this value set, and so I can populate a combo box or something. Now, as I said, the answer can be really complicated to determine, but if I'm using a terminology server, I don't need to do that. I just say, here's the value set, and what I'm doing is give me the list, give me the list. And maybe I can search it on your side with the text, so I don't have to think about it. Or maybe I want to know if the code is valid. Is this code valid in this value set? And I just pass you a code and identity of value set, and you tell me. I don't need to think about it, you just tell me. And I'll get an error maybe, and maybe I'll get back a display so I can display the code. Or I can say, is this code subsumed by that code? I didn't talk about what subsumed means, but it makes decision-making, clinical decision support simpler to implement. And again, you just pass a value of a value set or a code system, sorry, maybe, and 2 codes, and then it will do all the thinking for you. You don't need to worry about that. You can also get it to translate. Can I get this code in some other code system? Fill out a form, or I'm filling out a form and I've got to have the code in some code system, because I don't care. In your system, you don't actually need to care which code system it is. It's a code, I can reason with it. All right, but you can fill out a form and so you just pass in the code and the identity of the code system you want, and then you get back 1 or 0 or matchy codes, and you have to sort through them. You can't hide all the complexity, but the terminology server does all the thinking. And then the hardest part of all, anybody with a real system is doing some kind of SQL joining. It doesn't have to be SQL, but some kind of joining. We've got a set of resources, they've got codes, there's some criteria, and you want to mix that criteria with other criteria the terminology server knows nothing about. So the terminology server knows how do you meet criteria. The SQL server or whatever database approach has to do the joins. And so the terminology server lets you build a closure table incrementally. And I don't have time to talk about why, but it does. That's the hardest part. And this part we don't have exercised the least. But for me, it's critical to close the circle. Otherwise, you can't delegate out to a terminology server. All right. So using a terminology server, you just need to know the value set URLs in your application. You just need to know the codings, and you don't, and just let the terminology system deal with everything else, the service. You don't have to write a subsystem to manage the content. You don't have to import them into something. You don't have to have a specialist team. You use a terminology service and bingo, it's all fine. All right, so make it simple. Let the weirdo experts like Michael Lawley, who's a great mate, handle all the terminology details, and you don't have to worry about it. You can just write great apps instead without bleeding on terminology. And there are good servers available today, so you should use one. Right. So are you a lord of the terms? Well, I have an IP there. Your terminology usage tells people about your values. So invest in good terminology management, use a terminology server, and you too can rule the known universe of healthcare IT. And that's where I'll stop. And questions. See that. Stop share. I hope you enjoyed my quick overview. And I'd like you all to consider, actually, if you're not using a terminology server, consider using one. I see a question straight away in the chat. What terminology servers do I recommend? I couldn't possibly recommend a terminology server. I've got one and it's great, but it's probably not suitable for everybody else. Michael's about to tell you about one and it's great. And Nikolai's about to tell you about one, which I haven't seen. This is probably great because Nikolai's. But there's other ones, Ontoserver, VSAC. I'm not going to tell you which one to use.
May I ask a provocative question?
That's what you do, Nikolai.
Is YuCum terminology or not?
Yes, it's a terminology. It's a code system. We think of it as a code system, but it's a slippery, grammar-heavy code system. And you really need to have code, programming, developed code that understands YuCum. But there are free libraries available in Java and .NET and some other languages that do all that for you. So you can just use those, and you should. But yes, they are definitely code system terminologies.
Do you think into built in some YuCum conversion deeply into FHIR server? Because if people storing, let's say, observation in different units, but they want to search, so we get the problem because some temperature maybe in, I don't know, Fahrenheit and some in Celsius, and how you can deal with such data which are stored in a different format. Some kind of canonization, I don't know, translation on fly.
I can tell you that what I do in my server is that I store, when I index a quantity field, I store the stated quantity, and I store the UCOM canonical for that stated quantity.
Mhm.
And so if you search, I'll search by either method on the fly, but so that you can search across units, because I actually search twice, once for explicit matches to the stated unit and once for anything that matches the canonical unit within the stated precision of the source unit. But in order to do that, you do need a good UCOM library, and you need a good floating point library that handles imprecision well. But if you have those, then, and you should be able to assume that for me, you should be able to assume that the FHIR server can handle UCOM-based reasoning, but lots of them can't. So we didn't make it mandatory.
Yeah, because I can imagine kind of operation where you can ask by parameter, please translate me, let's say, some units into my local units. So I want to get it in these units. But this is kind of transformation of original resource.
Yeah, I mean, it's allowed by the server, but we haven't given the client any way to influence it. We could talk about that.
Thank you. Guys, any questions? It's a good time to ask question.
Hey, Graham, it's Abdul Malik.
Hey.
Yeah, I certainly agree with your advice about using a terminology server, but it does seem like it would be important to know exactly what concepts are handled by the server. I mean, most of the standard does not include required bindings. So you got all these expansions and permitted and examples. How do you know the terminology server you're using even knows the concepts you're interested in using?
So you can ask the terminology server directly. There's a special mode for the capability statement where you say, hey, give me your terminology capability statement. And then it will list you a bunch of features that it supports, and also the code systems that it supports beyond the code systems that are explicitly available. Otherwise, you can search its code systems, value sets, concept maps.
Sure.
Mostly that covers the space, mostly.
Right. And did some of the terminology servers then allow you to add new content, like add new code systems and mappings and concept maps like that?
Yeah, so like the one I run at terminology.tx.fire.org is read-only. You actually have to ask me. But for instance, the one Michael runs, you just, if you have the rights, you can upload resources directly to it, and bingo, it supports them.
Okay, good, thank you.
Lovely background, by the way.
Yeah. Up in Ventura today. We were in Sequoias last week.
Okay, and so you see a good question from Mark Kramer. Hey, Mark, UCOM is not closed. Of course, it's not closed, and neither is SNOMED, actually. And in fact, there's a bunch of clinical terminologies that aren't closed. UCOM is just more obviously not closed. And so, yes, there are things that you need to know when you're handling a non-closed terminology. One is that you can easily find expansions that are not limited. You can just keep expanding because you just keep adding things to, adding variant expressions. And so very often you can't expand these value sets and get every valid code. And that's, for me, that's the biggest difference. You can still reason with them, you can still do work with them, but you can't just go, hey, give me all the list of codes. You've got to say, hey, give me the list of codes that match this text, or give me a subset or something like that. And I think that's the hardest part of using non-closed code systems.
The funny thing is,
I'm always happy when I agree with Michael.
Yeah, I guess I'd call them naming systems, but that name has been used by our terminology folks for something completely other. It's like you see a new animal and you name it according, like, suppose it's a new genomic animal, quote unquote, that you've never seen before. You use the system of naming that's presented by, the code system. That's a naming system, and I was always so confused by the use of naming system for things that are obviously not.
So you can blame me for that one. It's
right.
not the terminologist. I chose the word naming system.
I blame you.
Yeah, you blame me. We never changed it. On the other hand, I criticize value set as a name, but also I should criticize code system as a name because it's actually concept management system, not code system, which is kind of at the root of your confusion, right? But what we said is we started with simple lists, code systems, but then they turned out to be there's no, clean division into what you're calling naming systems. And so really we folded them in and we should have renamed it at that point. But we couldn't even rename value set. So we certainly couldn't rename code system. And hey, the terminology about terminologies illustrates all of the problems quite adequately.
I think there's another particular difficulty that crops up, especially in grammar-based terminologies, and that's the issue of equivalent codes. So you can't do a lexical match to determine if two codes are equal or distinct. You really do need to understand what the grammar says, and in some cases what the hierarchy says as well, to be able to determine whether two codes are equivalent.
Totally. That's why you should use the terminology service. So that Michael does all your work for you.
But I think that the grammar-based terminologies probably may be decoupled from the terminology. So we say that terminology kind of depict the set of concepts, ideas, yes? And we have a grammar, which is near to the kind of algorithms and the code. And I'm still not sure that the grammar stuff is a terminology. It's a piece of algorithm. It's a piece of code. Yeah, and so
yes and no. I'll tell you why I said no. The reason, so first of all, when I sat down and actually defined the first code system resource, long time ago now, I actually sat down and reviewed all the existing grammars and frameworks to see if we could come up with some kind of common algorithm. There's no, or if there is, it was beyond my complexity to imagine it, let alone describe it, let alone get it right. But the other thing is that you sit down with your framework and your grammar, and then you define the concepts for the grammar. And so they're tied together. Yeah, they're separate, but you can't separate them management wise because you define concepts for the grammar that you're using. And that's why we just said bundle them all up in one thing and let the terminology service suck it up.
Nikolai, I'm wondering if I could ask a follow-up question from your perspective. When you talk about those grammars as being separate, do you include SNOMED CT in that category?
Yes, I'm very influenced by the semantic web and stuff like descriptive logic, and there are clear separation between the grammars. So they introduce very small amount of grammars like first order logic, but they have a T box, which is called terminology box, which is a concept, and they have a box, which is assertion box. It's data, it's facts, and they have a link between them. And on top of the T box, you can start doing some what's called sorry, it's not deduction, but so they kind of inferencing. Yeah, they start doing some inferencing by some kind of grammars like ISE and stuff like this, and they separate this. And for me, the terminology is just a concept, list of concepts. This is words, but the grammar is almost by definition, it's infinite. Yes, if you introduce a grammar and you have words, so you can build, I don't know, unlimited number of sentences from it. And I'm still curious that potentially the informational model of FHIR, it's still kind of mix of terminology and grammar as well, because the data structure is a grammar. It's a very limited, but it's a grammar. Yes, it's a static grammar, and the name of elements, it's a terms, it's ideas. Yes. And
yeah, I mean, I considered making that more explicit, and I considered, and in fact, the definitions of FHIR are very terminological. That was deliberate. And I considered, you and I discussed a concept resource, which would make that even more explicit, but no, we got voted down. So it's not that explicit. but it's certainly true, and that's how it actually works underneath. Yes.
And Josh, what is your opinion? I think you asked it because you want to share your opinion on this.
Honestly, I don't have one. I've become, whatever is on the low end of Graham's spectrum, on the opposite side of a lord of the terms. I'm still in the world where most of the terminology work I do works just fine if I can just define 10 codes for myself and get on with things.
That's true.
Yeah.
And I don't want to disparage that approach, Josh, but my experience is sooner or later there's a car crash heading your way. So just, keep your eye open, keep your eyes open.
No, I appreciate it. And I'm joking a little bit, but I started off 10 years ago. I was on the other end of the spectrum, doing almost all of my work in the semantic web space. But it's been a long time since I've thought about A boxes and T boxes.
But something that's particular to that space is reuse. So a terminology that imports another terminology and reuses parts of it or extends it. That's something that you can't do with a FHIR code system today. And in particular, for some examples, the human phenotype ontology imports about 11 or 12 different other ontologies to construct itself. So that does cause some issues when you're moving across those boundaries.
And I have a strange question. I'm not native English speaker, and why the code and coding kind of synonyms? Is there some deeper linkage between the codes and coding as a programming? Do you see it or not? So we have a codes, yes, and terminologies, so symbols, but we still call it codes. And we call the code our programming code, our programs, yes. So we do it with the code. What the kind of deep linkage? Why we use the same word for both?
Because we're really good at terminology. That's why. But,
okay.
I always figured it would be forbidden to have any element using a plural. So you couldn't say code and codes.
Yeah.
So I had to come up with a different word.
Yes, we don't have enough words. It's like asking profile or template.
But maybe this is a hint. Maybe this is a hint. I mean, about some kind of deep structure or stuff. Because when I started preparing my presentation, I initially go to some philosophical adventure, and I start thinking what means the structured data. And I understand that the machine really needs the codes to work with the data. Otherwise, it doesn't have any semantic understanding, the meaning of the data. Yes, so machine can only work with the codes. It bad with the interpretation of text or string. So it needs codes. If you want to write, if it's mail, you need the code. If you want to write some algorithms, if you want to write the generalized program, you need some is-a relationship for the types. Then you probably can write a program which can handle different type of data like in a. And I think this is kind of interesting linkage that the code need codes. Otherwise, you could not write your program because I don't know. You should use regex or something like this, or some grammars. It's just a philosophical remark.
Maybe let's turn to Nikolai's presentation from here, right?
Okay.
Yeah, so let me present Nikolai. So Nikolai is a founder and CTO of Health Samurai. He leads the development of Aidbox FHIR backend, which in particular has FHIR Terminology Server implementation. And because Aidbox is used in many real-life implementations, I'm not surprised that Nikolai's presentation is called Practical Approach to FHIR Terminology Services. Nikolai, it's all yours.
Okay, thank you. Can you see my screen, guys? Okay, so here. I initially started this presentation and go to some philosophical way, then get back, and because I remember that the name of this presentation is practical, not theoretical. So yeah, Pavel already introduced me. Yeah, we're doing the Aidbox, which is a backend, and we believe in the FHIR first systems as the foundation for the future health IT. So we're gonna speak one language everywhere. And that's all my slides. I want to switch to the notebooks and make my presentation kind of interactive. So the codes are very popular element type in FHIR. So we store FHIR metadata in database, every element, every attribute as a separate record. So I can query it, and we see that it's on the second place, I mean the codable concept. But if we sum the codable concept, the code, and the coding, I think it's gonna be on the first place. Yeah. So we see the codable concept, it's 800s, and yeah, the code. So it's a first place. So the most of elements, not the most, I think third part, a little bit more, it's coded elements. And I already told that I think in that that's the only way the machine can reason about the structured data. So the machine needs codes. And the rest of presentation, what means the practical terminology? We understand that making terminology is hard. Designing all these terminologies, it's hard, but when we start talking about the working FHIR server, we need a very small amount of working features. Like we need some way to distribute terminology, so easily load it into the server and update the terminologies. So we need some lookups through the value sets of code systems to populate the combo boxes and stuff like this. And we want to validate codes, which essentially is the same as a lookup, just kind of batch lookup, and probably test for subsumption. I don't think the subsumption is the only way we can use the deeper structure of the terminology, and we discussed the YUKUM. But that's almost all we need. And what's wrong with the code system and value set? FHIR has a very nice terminology framework, but from technical point of view, the code system, as Grahame already said, may be really big. And from the technical point of view, to working with a huge JSON with 1,000, 100,000, or millions of records, it's a nightmare. So you could not update it, you could not load. So it's a very inconvenient form of representing from technical point of view, distributing the code system. That's why we still have to load some CSV files from Lawley or from ACD10 and convert them somehow internally. So every server have to do it by themselves, reinventing the wheel. And the same about the value sets. So value sets, interpretation of the value sets may be complicated, and sometimes it's even incomplete, so it needs some manual fixes to make it work. But in a runtime, not in a design time, you can just kind of pre-expand most of the value sets. We understand there are some generative code systems, but we are talking about this kind of 80%, which 20%, which cover 80%, so most popular stuff. And then thinking about this, initially, I started thinking that it's hard to work with a huge code system bundle, but inside the code system, we have a concept, which is not resource in FHIR, but it looks very suspicious. It looks like FHIR resource. And starting from this technical initial steps, so I start thinking, so if we think about the coding logically, it's a link. It's a symbolic link to the concept. Yes, it's a symbolic link from the world of data, of facts, to the world of ideas. and the concepts. So it behaves like a link. So we just, for this link, we just need not resource type and ID, but we need the system and the code. So as well, if we're talking about the validation of the codes, it very similar to what we call the referential consistency. So we're checking that this code exists. So they share this property as well. And let's imagine that we can kind of introduce the code, the concept resource. So let's think that we have a concept resource, and let's see what we can get from it. So the first, what I see that we are getting this operational framework from FHIR specification. So now if we imagine that we have a concept resource as a resource, so we can use a search, and it looks like the search can cover all the lookup and filter can do even more. And as well, we have a CRUD operations and the bulk API, which is maybe very interesting way to distribute terminology in a standard way. So you don't have to load CSV, convert and process it. So probably somebody will prepare it for you and you just run the bulk API. So, and we did it in Aidbox maybe a few years ago. I wrote a post about this. So, and I will show you how it works. So we have a table concept. I just cleared it up. So let's create just a couple of concepts. So let's say we have a resource concept and we're just creating a couple of concepts, and it's just a CRUD. So we just observed these concepts. So, and now we can search for these concepts. So this is some strange stuff, but we can use, for example, only select elements and code, and we create a search parameter system and we filter by system. And we have a kind of, I like extension for the FHIR search, which is very handy when you're doing some code is complete in the combo boxes. So now we can just select this searches, and this is cover the lookup functionality. And if your FHIR server or if you already implemented the search, so you can reuse it. Okay, so now then we come to the value sets. So what means a value set? We understand that one concept potentially may belongs to different value sets, but let's introduce a value set field, which is just a collection of the value set IDs or URLs, and then let's update. So now we use, again, we update the same concept, so we can easily use the CRUD for management. And then we can filter by the value set, and so it works. And we can even add kind of additional filter like and search for the phone, for example. So we're getting this, so it's working. It's reusing the same way. Now we come to the distribution. Yeah, we understand that, and what I see that a lot of complexity. So we're doing the terminology stuff more than 10 years, and it's always hard to load the specific terminology, parse it, and it's even more hard to keep it up to date. You have to pull for the changes from different sources, and then somehow to update it in your terminology server. But for example, we have a very nice bulk API, and this way, this operation can be used to just bulk load the terminology. So we prepare the small ND-JSON ACD10. So this is kind of specialized operation, but essentially it's the same as a bulk operation. So we can run it. So it's in real time, and we loaded this 44,000 concept from ICD-10, and let's search through them. So, and we see it here. So you see it as an array because we have a kind of extension which shows it without bundle. So no, some informational noise for you. So we got the ACD-10 in a few seconds. If somebody prepared it for you, you can get it working in a few seconds. Just get the link to the bundle, load it, or even update. So it works, and we can search. We can even create the search parameters, which search in a smart way. I don't know, we can search through I like. So there is a lot of interesting stuff can happen. Okay. Yeah, yeah, this is how we can search. So it's really working. It's quite fast to load, even without indexes. What's another interesting feature that if the concept is a resource, it has a properties, you potentially may search by other properties, not only by code and description. And that's open through the standard search API. And that's open another possibilities in your system. So you're not limited to this stuff and to prepare kind of some value sets before. If you want to filter lowing by method or something like this, you can do it through the search parameters. And we have a interesting extension which allows us multidimensional search with some prioritization. And for example, it can be applied here. So you can initially search by display and after that search by names, so that if you find something by display, it will be in top rated, and then it switch to search by names. It's kind of alternative names. So, and we see, for example, we were searching for depression nose, and it didn't find it in display, but it find it in a alternative names. So that work as well, and you can even write the profiles on concepts and create an extensions on it and keep this data with you, because the more sophisticated scenarios may need more than just code and system. Yeah, okay, what about the subsumption? So again, let's clear it. So how we can model the subsumption? So let's load some hierarchy of the concepts, and we can model it very easily with, for example, the parents collection. So we create the concept C1, then the C2, which is a child of C1, and the C3, which is a child of C2. And so let's load this. And then we can kind of create a search parameter which search in the parents. And then you can easily express a subsumption as just a search parameter. It just look for the concept which has in parents specific code, and we filter by the system. So, and most of FHIR servers already have these capabilities to define the search parameters and other stuff, and this will work. As well, Grahame said about the joining, and the sophisticated scenarios need the joining or the chaining, and probably include to get some data from the concept, additional data, even the display, or maybe translation of the display. And if the concept would be resource, I can imagine that we can use a include and chain it params and the other features of the FHIR server. So that's all. I know I open to the questions. So this is kind of proposal. I think it's not hard to switch, introduce this stuff in FHIR, because I think the most of terminology services do the same. So they at least cache the expand of value sets. They keep concept as a separate record in a database. They do not keep it as a huge JSON file as a code system. And what's more important, that I tie it to process all the CSVs. If somebody can prepare this ND.json file with a concept for me, that will be very nice. So then we can kind of exchange and share this stuff. Okay, that's all. Thank you, everybody. And this is a notebook, so you can register on Aidbox Cloud. It's free, and so we have a notebook section at the first, and you can find this notebook and play with it from your laptop. Try to break it. Thank you.
Thank you, Nikolai. Let's get the questions.
Yep.
You can check the chat first, maybe, or people can just start shooting questions at you.
Yeah, I see one question about the versioning. So then it's the same as I have an opinion about the versioning. So from my point of view, it's a best practice. Don't change the meaning of the codes and never delete them, because if you look into real system and how it's evolve with the time. It's a bad practice to delete the codes. It's a bad practice to change the meaning of the codes. From this way, I would just introduce a deprecated element and allow only deprecate stuff and never change the meaning. But potentially you can introduce the attribute element, the version. It can be even collection. So, or it can be the upper version, or it can be the date, wallet from, and wallet until, like the SNOMED do. So there are plenty of stuff how we can handle this versioning with the concept resource.
So you'd have a single instance of a concept and you'd push the versioning information into the properties attached to that concept.
Yeah, you always, so because so in for example, in our implementation, the ID of the concept is not linked to the code and the system. So you potentially may have a duplicates. So you may have a duplicates with different value sets, and you can even kind of use a value set plus ID as a filter for these concepts. I think that most of terminology services do it internally, but here we just make it explicitly.
Starting to remind me of ISO 11179.
Can you elaborate on this?
Metadata repository standard by ISO. It describes something called a data element concept and then a representation. So a data element is a combination of a concept and a representation. And it's a metadata model, basically.
Yeah, definitely.
But it's also a rabbit hole.
Thank you.
Any other questions?
Yeah, I see the question in the chat that yes, the concept is not an official FHIR resource, but we just took the kind of element from the coding system, which looks like a resource. Graham,
Yeah,
what do you think about? Yeah,
I was going to say, I think concepts don't and aren't created in isolation. They're created as collections, in the context of a set of other codes or concepts as a terminology. So they're not managed individually. They're not generally updated individually. So from an implementation perspective, yes, under the hood, you generally have separate concepts in some form or other. But that's not the way code systems are managed. And so I think this potentially is just exposing implementation convenience or details rather than capturing the way the domain operates.
probably, but look how convenient is it. For example, so you have your huge code system and you change just a couple of concepts. And with this implementation, you just can do kind of insert two new concepts and maybe update a couple of others instead of loading again the thousands of concepts. So, but they can be united by the code system. I mean, by the system URL, the value set, the version. So they logically they are the united. Yes, but I'm just talking about from the technical perspective.
Yeah, I wonder if you can do that sort of individual update with the patch operation.
Yeah, definitely you can do this. And I think, so what we kind of using Aidbox to implement kind of EHR-like systems. And there is a lot of local terminologies which the system should handle. And often people want to make the dynamic, they create the user interface. So the, I don't know, physicians or some administrators can update these terminologies. So that's where this CRUD framework, CRUD operation from very handy. So it's easy to create such type of interfaces for local terminologies.
We have time for last question for Nikolai.
Yeah, I see the phrase from Grahame. Another reason, so we for now in the market, we have a lot of FHIR servers which already implemented all these operations. I mean the search and CRUD. So that, and not so many terminology services. I still see a lot of market for the terminology service for the design time when you're designing the value set, when you're doing all this stuff. But after that, it can be dumped into JSON and loaded into multiple instances of FHIR servers. So again, it sounds kind of technical, but I think it's still interesting. So by adopting the concept resource, the more FHIR servers will become the terminology, at least runtime terminology services, not design time.
By the same argument, at runtime, you're not updating at the individual concept level. You're just getting a dump of entire code systems.
Yeah, I mean, so we have a value set, which is a rule, yes, which filtering some concept from the code systems and excluding, including. So implement this is quite hard, yes, all these filters and all this stuff. And that's when you're designing the value set, that's what I call design time. And for the runtime, I mean when you're just looking up the codes, validating the codes, what's usually FHIR servers need to do. And the separating the terminology server from the FHIR server has some performance implication. That's why I still think that runtime terminology, which is located at the same database at the FHIR servers, is a still good thing because we see that more and more data in FHIR. So
I think we probably can hear from Michael actually how they solve this problem, because I understand they do separate terminology services, which is used with other FHIR solutions. So let's switch to Michael's presentation. Let me introduce Michael. So Dr. Michael Lawley, he leads the Health Informatics group at the Australia eHealth Research Center. They develop FHIR terminology services called Ontoserver. They call it the next generation terminology services. And yeah, and it's used very often outside of another FHIR solution. So Michael, please, it's all yours.
Okay, share my screen. Yeah, so yes, hello everyone. What I'd like to talk about today is our terminology server, how we, well, not how, but the parts of the terminology specification we implement, and some of the challenges and key issues, design decisions and design criteria that we have around it, and some of the things that go beyond just the FHIR APIs. So firstly, just a little bit of background, because I'm pretty much on the other side of the world from most people. I come from the Australian eHealth Research Centre, which is a part of CSIRO. CSIRO is Australia's national science agency, and the eHealth Research Centre runs the digital health component of our national research agenda. I've been working on terminology servers for much longer than I care to think about. I guess that does make me a weirdo, Grahame. And Ontoserver started as a proprietary system, and has transitioned to be a FHIR native terminology server. It's been the core of Australia's national terminology service since 2016. It has more than 1,300 registered users, more than 90 sub-licensees in Australia, and we've got, of course, commercial licenses around the world. And so Grahame's done a really good introduction about the FHIR Terminology Services picture, so I won't go into any great detail here. What I will talk about, though, are sort of the variety of use cases that we seek to address with the terminology server. The primary one that we focused on originally with Ontoserver was the data entry use case. And again, we began our journey here with SNOMED as the terminology of choice. So we jumped in the deep end and started with the most complex thing we could find, and then everything else sort of came along for the ride. So searching for the right code, validating whether the code you've got is correct for the context, finding out the details of a code system, translating code from one system to the other, aggregating code, so arranging them into categories, and then, of course, building custom code systems, value sets, and concept maps. So these are all the use cases that we aim to support. One thing that's not on this list that should be also is providing a terminology service to an existing FHIR service. So if you've got a FHIR server and you're supporting search with code below or code in, then being able to call out to an external terminology server to support implementing that functionality without having to go through the tedium of implementing it all in your own FHIR server. So offloading all that work to a dedicated engine. So Ontoserver is out of the box a high-performance FHIR native terminology service. You can drop in any FHIR native code system, and Ontoserver will be able to support that with value sets that use the code system. And of course, it has dedicated custom support for SNOMED and LOINC. Some of the hallmarks and goals of terminology server is fast expand and search, and we don't pre-expand value sets, and I'll talk about that a little bit later on. So we want fast value set expand and search, so you can build live user interfaces. We're aiming at user interface use case, so the matching algorithm for when you do an expand with filter is term prefix any order, which is what the literature demonstrates is the best matching algorithm for searching for codes. And we have some custom result ranking, so that the results you get back give you the best match at the start of the list. From customer demand, we also added in some non-terminology capabilities, so generic FHIR resource validation. And part of that was so that the validator was directly using the terminology's capabilities and wasn't limited by its own terminology implementation. In terms of the core feature set, Ontoserver is currently FHIR R4, but we have begun pre-adoption of a number of R5 features. So there's a whole lot of changes coming to concept map in R5. Some of those we are in the process of pre-adopting. There's some additional parameters to expand, like bringing back the properties of a concept in expansion. Those we have support for as well. We have, of course, deep support for all the FHIR terminology resources and operations. We understand code system properties and filters. We pay a lot of attention to multi-version support, so you can have multiple versions of code systems, value sets, and concept maps loaded into the terminology server. It understands how to sort based on version. So if you don't specify a version in your value set definition, then it will by default use the latest version of a code system. If you specify a specific version, it will use that specified version. You can reference different versions of a code system in a value set definition. So you can define value sets that span code system versions where that makes sense. We support code system supplements. So a supplement may add in additional designations for concepts or add in new properties to concepts. When you're expanding a value set, it has to identify the supplements, any supplements it wants to use, so they don't inject themselves into your expansion automatically. You have to actually request them. Otherwise, you get you open yourself up to interaction effects where someone uploads a supplement and suddenly your value set starts misbehaving. We also have good display language support. So if you've got translations, you can request that the results come back in different languages. We have the idea of algorithmic concept maps. So these are some implicitly defined concept maps, so that they have a URI, a well-known URI. They are backed by an actual concept map instance. And this allows us to support, with the translate operation, automap type functionality. So either here's a code, find me a matching code in this target value set, or here's a string because I'm giving you, say, a codable concept with just a text. I'm giving you a coding with just the display. Find me a concept in the target value set that best matches this text. And then we have a resource level security model. So this allows you through security tags to mark a code system or basically any resource as being only visible to members of a community. Community membership is characterized by scopes in an OAuth token. And then you only get access to resources that you're authorized for. Your token says that you have authorization for, and that crosses the boundaries. So if you have a value set that's defined that you do have access to, but it's defined in terms of a code system that you don't have access to, then you won't be able to expand that value set. You'll be able to see its definition, so you'll be able to do read operations, but if it needs to access the code system to perform the operation, then that will be denied. As I said, we've got dedicated SNOMED and LOIC support, and we also have this content syndication model, which relies on the Atom XML format. We support all the terminology operations, including the obscure ones like find matches. And any of these can also be invoked through a batch operation as well. In terms of our dedicated SNOMED and LOIC support, with SNOMED we have very strong coverage of the expression constraint language. We used to have complete support, but the language has expanded substantially over the last 12 months. And so we don't have complete support, but all the core capabilities of the language we have support for. We support all the different implicit SNOMED value sets. And this gets to one of our design goals. we don't pre-expand value sets because we want to be able to expand them on the fly, because we want to be able to support value sets supplied dynamically. So if you define an ECL expression, compose the URI that corresponds to that ECL expression, and then ask that to be expanded, we'll expand that. You can add filter parameters to that to further subset the codes based on text matches and so on. All that happens dynamically and on the fly. There's levels of caching that go on under the hood that are designed to make sure that's fast enough to be used in a user interface. And of course, if you have a full FHIR resource value set definition, you can post it to the expand operation to get results that way as well. We support the implicit concept maps from SNOMED. So the SNOMED distribution also includes a set of map tables which are exposed as well-known concept maps. We ingest directly from an RF2 distribution. We understand how to deal with all the multiple versions, and SNOMED has a slightly more complex versioning system where you actually have a tree of versions because you have different national extensions, and each national extension then has its own set of versions. And we also include a classifier to support SNOMED post coordination. So if you build a post coordinated expression, you can do subsumption tests. You can put post coordinated expressions into code system supplements and use those with value sets where it understands their position in the hierarchy and so forth. And then we have support for the well-known LOINC implicit value sets as well. Stepping outside of the FHIR API into the syndication model of Ontoserver, one of the key requirements that we had to support was making sure the content in a terminology server was able to be kept up to date. And so for that, we implemented the syndication model. It's built around the idea that an endpoint can advertise one or more terminology resources as being available. The entry indicates the URI of the resource and its version, and then a link to where to go and obtain that resource from. Plus some other metadata, human readable names and that kind of thing, dates, etc. Then you can point an Ontoserver instance at one or more of these syndication endpoints and request that it go and get this version of this resource. It'll search and find that and download it, and that allows you to keep the content up to date. You can do this manually. You can set up a scheduled refresh, so it can poll the endpoints. There's no push, so you can't push content unless you have write. Use the normal FHIR APIs and just post the CRUD endpoints content in. There's no pushing through the syndication model into a terminology server. Each one retains autonomy and has control over its own set of terminology content. And what this allows is the development of an ecosystem of well-known syndication endpoints that provide governed content at national, state, and organizational levels, and so that you can keep up to date with the latest versions and ensure that things remain in sync. So in Australia, for example, we have a National Clinical Terminology Service. It provides a syndication endpoint. And then in the state of Queensland, we have a Queensland Terminology Service at the state level, which provides additional terminology content that's relevant to the Queensland state health system. And then anyone can participate in that ecosystem to easily access that terminology content. From a technical deployment perspective, we deploy as Docker. So you can do as simple as a Docker compose to spin up an instance, or more likely a Kubernetes-based deployment. You can deploy locally in the cloud. We have some sample Docker compose deployments. We've got Kubernetes ones in the works. And so you can go from a very simple single instance kind of deployment, very easy to spin up, to a complex multi-node deployment with a terminology server where you do development. You've got in-flight resources, a custom syndication server that can provide multiple feeds, scaled read-only endpoints for high volume usage, all secured by a authorization server. So we embrace Smart and OAuth 2 for our authorization model. And so you can build up a very complex deployment. And we have customers who some of them have a very simple deployment like this. Others have much more complex deployments like this. In particular, the UK has deployments like this, actually with multiple read-only endpoints to serve different use cases. At sort of national levels, we have deployments in Australia, England, Wales, the Netherlands, other countries coming online. We have hospital consortiums that run a network of terminology server instances. For example, the HIMIC consortium in Germany. We have software vendors, clinical colleges, the whole range of users from small research operations up to the national level. And we also run our public sandbox that Grahame mentioned. This is a bit of a Wild West because anybody can write anything into it and does, and changes and deletes things. So there's no guarantees there. It really is a test endpoint. But it also supports our terminology browser Shrimp, free browser Shrimp, which serves also as a demonstration for kind of performance and capabilities of the terminology server. So coming around to the technical challenges. So I mentioned this already, the goal is fast and dynamic value set expansion. So we need to be able to expand value sets that we've never seen before with a performance level that's suitable for use in the user interface, and that supports code systems on the scale of SNOMED CT, including complex things like SNOMED expression constraint language, dealing with cross-code system value sets and cross-version value sets. So that has been quite a challenge. And the basic way we do that is that when we take a value set definition, we compile that into a single query that runs across the indexes of all the relevant code systems. So we have a series of Lucene indexes under the hood, and we're able to turn any value set expansion or any value set definition into a single Lucene query to evaluate. That's where we get the core of the speed from. We also have custom scoring in Lucene that gives us the sorting that we get out of expand with a filter parameter. And then to make that even more complex, the code system supplements mix in additional Lucene indexes. And so keeping those all aligned is quite a challenge. But that's where I guess most of the real under the hood complexity comes in. To deal with post coordination in SNOMED means we need to fold in a description logic classifier that runs fast enough. And we cache the results of running the classifier. So the basic strategy for post coordination support at the moment is that the expressions need to be supplied via a code system supplement. That allows us to pre-classify those expressions and mix the results into the indexes that support expand. The other key technical challenge we have is that with our syndication model, we don't have control over what version of Ontoserver any given syndication client happens to be running. So it means if we ever update the Lucene index, that index has to be usable by all those old clients. And so we need to maintain both forward and backward compatible Lucene indexes. It means that new versions of Ontoserver may be getting old indexes, and so we have to be able to handle that as well. There are mechanisms in Ontoserver to automatically upgrade indexes from an old version to a new version. But in the case of SNOMED, that actually requires access to the RF2 source. And if that's not available, then we still have to be able to sort of move forward or keep working, but in a limited or a minus a few features. So managing that and managing the governance around the Lucene index versioning is quite a challenge. And the last technical challenge is really one given to us by SNOMED and the way SNOMED manages multiple languages. It actually doesn't just do multiple languages, it does different languages in different contexts. They can be specified dynamically. And so we've adapted the language support to be able to specify not just the language, but the dialect via a reference to the corresponding SNOMED reference set, so that you can get the particular dialect of the language that you prefer. Looking to the future, we're looking at more R5 features as they stabilize, and customers are wanting them now rather than when R5 actually comes out. And we're also looking at how we might be able to support R5 and R4 in the same server. At the moment, we have a version that supports STU3 and a separate version that supports R4. We're hoping that we'll be able to support R4 and R5 together in the one server. We do support convert, so you can and the appropriate version headers, but all you're getting there really is a translation of the results. You're not getting a deep cross-version support. There's a new version of ECL2 coming out hopefully in the next few weeks. And so we've been busy working to support that. The key thing of interest there is it goes to retirement of concepts and historical concepts. So the way SNOMED does versioning or treats retired concepts is it marks them as inactive. So it doesn't delete them, it just marks them as inactive, but they also drop out of the hierarchy. So they lose all their relationships and they lose their parents and children. This means when you're doing queries against your data and your data is historical, it's got old codes that are retired, they probably don't match your value set selection criteria. So ECL2 adds some new features that allow you to more easily bring in those retired concepts via links from the active concepts that point back at the retired concepts that they replace. We have some work in the NLP space that is looking to produce some more high-performing algorithmic concept map or code matching, code translation capabilities, and we're hoping to roll those into Ontoserver. That's a longer-term work in progress. And we're also looking to improve the post-coordination support as we get feedback from customers actually using it. So at the moment we have minimal support for SNOMED post-coordination. And as we get feedback from customers as to what they do and don't need, we'll be improving that capability. Of course, Ontoserver, it's the backend service, implements the APIs, but that's not enough on its own. So there's a front end single page web app, Onto Command, which gives you a UI to the terminology server. But then there are some other clients. So there's Snapper, which is another single page web app, supports Smart Launch. So it conceivably will work with any FHIR terminology server. And we use that for authoring the terminology resources, just small ones. It's not a collaborative authoring tool, and it's not for big things, it's for small things. We have Shrimp, which has evolved from a SNOMED browser into a general terminology browser. And then Atomio, which is a standalone syndication service, which handles the sort of the more complex end of managing multiple syndication feeds, logical feeds with different sets of content, and so forth. We have a set of open source tools, some FHIR terminology transforms, including one that does generic OWL to a FHIR code system, and others that work with specific, usually CSV oriented formats, but also CLAML. We have our FHIR Analytics server, Pathling, which builds off FHIRPath and allows you to do FHIR native analytics queries, and it uses Ontoserver to do all the terminology elements of that. So it's an example of offloading the terminology requirements to an external service. And then we have RedMatch. RedMatch allows you to design transforms from RedCap into corresponding FHIR resources. It can run batch or incrementally. So as your RedCap forms get updated and you get new data, you can rerun the transformations and get the appropriate updates of your FHIR resources. If you want to get a feel for the behavior of the terminology server in a user interface, there's a mock EMR available at this URL. It can talk to either our Ontoserver sandbox or Snowmed International Snowstorm server, which is a Snowmed specific FHIR terminology server. It's using the exact same calls to each one, so it gives you a feel for the utility of having a standard API, but also the slightly different performance characteristics of the two servers. This is the terminology browser. Everything in the browser comes from using the FHIR APIs and dynamic expansion. So the hierarchy view here is constructed from on-the-fly value set definitions, as is the diagramming, and all the properties that that are displayed come from lookup and translate calls. And then this is an interesting tool that I built, one connectathon, which allows you to send off identical terminology queries to different FHIR terminology servers. We've got a few public endpoints that we know about that are configured in, but if you have your own one, you can provide that. It'll send the same queries off to each server and visualize the results. So you get to see the different behaviors of expand, the sort of quirks of different servers. And if you click on an individual concept, it will do the same thing for a lookup of that concept. So it's a useful way to see how different endpoints behave and evaluate them to see whether they're suitable for your needs. And then finally, just some links to further your journey exploring Ontoserver if there's anything here that is of interest. And I guess I should now look at any questions that have come through.
Yeah, thanks, Michael. Yeah. Let's get the questions.
Yes, so this r4.ontoserver.co.au/FHIR, that's the endpoint for the public sandbox. How do we handle exclusion? So the way that the evaluation of a value set happens is that the value set compose has include and then exclude criteria. The semantics are that you do all the inclusions and then you do all the exclusions. So we essentially build a query, and otherwise they're symmetric. So we build a subquery for what the inclusions are, a subquery for what the exclusions are, and then the resulting thing is just everything in this that's not in that. And then that's recursive as you go down in case a value set includes another value set or references another value set and so on.
This is not 100% correct if you move the exclusion to the end. That's what we found, that you could not efficiently transform into the absolutely correct request, because if you're moving exclusion to the end, so then you can imagine value set which will miss something. So you're doing exclusion, then including something which include this code again. But if you move the exclude to the end, you will exclude this code.
But that's how value set is defined. It's all the inclusion criteria, and then you exclude all the things that match the exclusion criteria.
Mm-hmm. But potentially value sets it can be recursively nested. Yes, so you can.
Oh yes.
And that way, so you can move all the excludes to the end, but potentially you may have some.
Yeah, no, so when I say you move all the exclusion to the end, I mean at the level of that value set. So if you have an inclusion criteria that references a value set that contains exclusion criteria, you can't move those exclusion criteria to the end. You have to keep them essentially nested. Yeah. So you do get, when you have complex value set definitions, you do end up with complex nested subqueries.
But I think we're lucky that not so much exclusions in value set.
Yeah. Exclusions tend to be rare, and also nesting tends to be rare in our experience.
But I wonder what are your performance metrics, because we have cases when we have to load terabytes of data, and it's not just one kind of validation. Yes, so you're loading millions and millions of resources, and what's the time for the validation of one resource? I don't know, or 100 resources, 1,000, because it's becoming the problem.
Yeah, so I guess so our goal is that so it also depends how the validator is calling the terminology service. So this becomes an issue of optimization, because there's many different ways for a validator to call a terminology service, and if it's dealing with things one at a time, then that's usually going to be slower than doing a smarter interaction and doing things in a batch. If the validator is validating 1,000 of the same resource and with the same binding for the same field, then it could collect up all the codes for that field, all the unique codes for that field, and essentially do an intersection between those codes and the value set, and do that in one operation.
So the current validator doesn't do that, except in one particular specific place when it's validating a value set itself. I could re-architect it to do that, and I've thought about it, but there's a number of places, particularly when we're doing slicing, where the resolution of the validation is blocking for further process. And so they'll have to just go ahead and call it anyway. And it's just, no, I haven't done it. Maybe one day someone will get a bee in their bonnet and decide that it's worth that investment. But it's a pretty serious piece of work. And it's compromised by the fact that maybe a quarter of the calls end up being blocking one way or another.
Yeah, because when we start loading the terabytes of FHIR data, every millisecond is becoming a problem. even additional hop to the terminology server. So I can just imagine some in-memory data structure which can serve this validation efficiently, but it's really a problem. It can take weeks to load and validate data.
Yeah, but the other thing is that you may have millions of records, but you're not going to have millions of distinct codes showing up in those records.
Yeah, you definitely watch, but you still
option for caching, right? So you want to do caching, and that's really I think the key is putting the caching in at the right place, because then you don't have to go through the potentially complex process that Grahame was talking about of re-architecting interactions into batch interactions. You can still keep it simple, but you cache locally, and then you don't have to. You do the network traffic for the first call, but you don't do it for any subsequent calls. It's just essentially an in-memory lookup, and that should be very fast. That's actually something I should have mentioned in terms of the technical challenges, is properly dealing with caching. So for Ontoserver, any code system can be updated at any time. To support e-tags, which we do, you have to have those e-tags for, say, a value set expansion, aware of whether or not one of the code systems referenced in the expansion has been updated since the previous call. So we've got all that kind of logic in there as well.
And the last question from my side, how do you handle the closed terminologies like CPT, for example? I don't know, it's a pain. Always. I don't know how terminology can be closed, but share it.
Yeah, so we don't handle CPT. We don't have a license for CPT. So we've not seen it. We haven't yet had a customer. We only have one active commercial customer in the US. So it's not been something we've had to deal with yet. Of course, if you can transform, and this is a normal pathway, if you transform the code system into a FHIR code system, then you load it as a FHIR code system into Ontoserver, it will work.
CPT is not that big, we've seen that.
Yeah, but there's some license problems which we see potentially.
Yeah, you can't put it up on the can't at the moment put it up on the public web, although we have discussions around putting CPT on tx.fhir.org, full CPT. Maybe that'll happen.
Yeah, please do this. Graham, please do this.
Yeah. Well, if we can, we will. But I mean, it won't. We can only put it up there on some kind of license basis where everybody agrees that they'll have to license CPT to use it anyway, which they have to do. So, but we'll see.
Yeah.
Because it's funny situation. So you're forced by regulation to use CPT, but it's closed. You even can publish some descriptions. So.
Yeah, so we also support very large code systems through the FHIR code system resource. So I mentioned in the chat that we support DM+D, which is the drugs terminology from the UK. It's about 370,000 concepts at the moment. And we transform that into a FHIR code system of about 320 megabytes. And load that in. So we also have some dedicated support for ensuring that super giant code systems like that don't impact other users of the system. For example, when you do a search result, or do a search and you accidentally match a giant code system, you don't want to get back all the contents of that code system.
All right, any other questions for Michael? Or to any other speaker as well, like since we already seen all the presentations, we can get back to discussions around all of them.
Yeah, I think we discussed after each talk.
All right, so Mike Kulakov will submit a link to the chat with the survey about this meetup. Really want to ask everyone to spend a couple of minutes and answer the questions, because it's important for us to learn what worked and what didn't, and how to make the next meetups better. And if nothing else, I mean, I want to say thanks again to all the speakers and everybody who attended. Thank you so much.
Thanks for organizing the session, guys. It's I think it's been good. The feedback, I've got a bit of private feedback as well, and it's been, most people have thought it was really useful. So thanks very much.
Yeah.
Thank you, everybody.
Yeah, have a good day, night, wherever you are.
Yeah. Thank you, everybody.